Today we are starting on, we're on unit 3.7. Okay. 3.7, what we're going to work on today is we are going to factor quantities. Factor quantities. Okay, factor. Factor essentially means to divide, okay, because we are breaking things down. So factoring is actually dividing. And quantities are when something is in parentheses. Okay, so in parentheses. Okay, so a quantity is something that's in parentheses. So to start out, I would like you to factor completely 100 y squared minus z squared. Factor 100 y squared minus z squared. This is just a little bit of a warm-up for you today. This isn't what we're doing all today. You're going to be okay. Okay, so hopefully you recognize the first thing you have to look for is a GCF. There is no GCF here. There's nothing that both of them have in common. Then you count up the number of terms. There's two terms, so the only kind of factoring you could do would be difference of squares. So look at both of these. Yes, there's a difference, so that means you're going to have 1 plus, 1 minus. Both of these are squares, so 100y squared breaks down to 10y and 10y. Z squared breaks down to z and z. So just difference of squares factoring. You've had some of that on your quiz today. Okay, now, very similarly, but not exactly the same, would be something like this. If I gave you quantity a plus b squared, so a plus b quantity squared, I mean to put it in parentheses, minus m squared. Quantity a plus b squared minus m squared. Now, this is essentially the same thing, but it has a quantity in it. It has a parentheses in it. Now, a lot of people don't like to deal with the parentheses, so what we're going to do is, instead of having this parentheses, I'm going to substitute it out. Okay? I don't like that parentheses, so instead of having a plus b in the parentheses, I'm going to substitute out for a q. I'm going to use a q because hopefully in your head it's going to kind of signify to you, okay, that's a quantity. I'm taking it out, so later I have to put it back. Take something out, you're going to have to put it back at the end. Okay, so if I just rewrote this, but substitute for q, if I just wrote q squared minus m squared, now it looks like a whole lot easier problem. So it's not that you can't factor with the original quantity in there, you could, but it becomes a little bit more difficult just because the way it looks. Our brains just, it looks too complicated, and so a lot of people will just stop and say, oh, I can't do that. You can factor that. That is just difference of squares. So if you factor that down, you're going to have 1 positive, 1 negative. Q squared breaks down to q and q. M squared breaks down to m and m. Now, I would recommend using a different color or something so that then you realize, okay, I'm not done yet. Now I have to substitute back in. Okay, and if you substitute that back in, it does still need to be put in parentheses, so a plus b plus m times a plus b minus m. Now, sometimes we're going to have a number out front, like if I'm doing a leading coefficient trinomial problem. That's why we leave this in parentheses. Then once you know that nothing has to be distributed through, then you can drop the parentheses. So your actual answer is a plus b plus m multiplied by a plus b minus m. And that's the answer that I'm looking for. That is factored completely. And it is okay to have a trinomial, so 3 things in there, multiplied by another trinomial. That is okay. Okay? There's no rule that says you can only have 2 things inside your parentheses when you factor. Okay? Try another one. I would like you to factor 9 times x minus y quantity squared minus 49. 9 times x minus y quantity squared minus 49. Now, like I said earlier, when we have the quantity in there, it looks more confusing. So instead of that quantity, I'm going to substitute out x minus y, and I'm going to substitute in q. Okay, so kind of write yourself a note, what you're taking out, what you're putting in. If I rewrite this, that's 9q squared minus 49. Now, in all of these problems, even if you substitute out, we still need to look for a GCF. This does not have a GCF, but it is difference of squares. Difference in the middle, both things are squared. So break it into 2 parentheses. One will get a plus, one gets minus. 9q squared breaks down to give you 3q and another 3q. 49 breaks into 7 and 7. Then once it's been factored, you can multiply back through, or excuse me, substitute back in. So 3 times x minus y minus 7 times 3 times, oh, thank you, plus 7. 3 times x minus y minus 7. Now, this is why you have to leave things in parentheses, because here this 3 gets distributed to both the x and the y. If you forget the parentheses, a lot of people will just distribute it to the 3, and that would be a mistake. Okay, so distribute it through 3x minus 3y plus 7 times 3x minus 3y minus 7. That is factored completely. So it's nothing that you haven't done before. We're just adding another little component to it. Okay, but it's still the same thing. It's still difference of squares. Okay, it is still the exact same thing. Now, sometimes you're going to see problems like this as well. For number 4, if I give you x squared plus 4x plus 4 minus 81c squared. Now, if it's in parentheses like this, hopefully it kind of keys into your brain, okay, there's a reason this is in parentheses. If it wasn't in parentheses, I mean, it could just be written without the parentheses and nothing would change here. But there's a reason it's in parentheses. And the reason is, this is a quantity squared. What is this? What's another way to write x squared plus 4x plus 4? X plus 2 times x plus 2 minus 81c squared, which is also written as x plus 2 quantity squared minus 81c squared. So if you rewrite it, it is technically the same thing, but now you could recognize this as a quantity. Okay, so we're going to take out the quantity x plus 2, and I'm going to substitute in for q. Then rewrite this, so this is q squared minus 81c squared. That will factor, that's still a difference of squares. So that factors to give you q plus 9c and q minus 9c. Now that it's factored, now you're going to plug back in. So you get x plus 2 plus 9c multiplied by x plus 2 minus 9c. There's nothing in front, so nothing has to be distributed, so you can go ahead and drop those double parentheses and just get x plus 2 plus 9c and x plus 2 minus 9c. That is fully factored. Okay, fully factored, yes. Okay, if it wasn't a square, then you wouldn't be able to do difference of squares. So if there's a weird number in front, something like a 5, or, you know, especially like a 5 or a 3, something like that, then that would kind of signal in your head, okay, I probably have to take out a GCF first before it will become a difference of squares. So you're not going to see anything on here that's going to be a prime, for example.
So no prime answers, basically?
No prime answers, no. And I will check for you, but I am pretty sure, like 99% sure, there are no prime answers on your test as well. So no primes. Okay? X squared plus 12x plus 35. X squared plus 12x plus 35. This is not a quantity, but it's still factoring. I still want you to factor completely. Okay, first look through for a GCF. Away, please. First look through for a GCF. Then there's no GCF, so I count up the terms. That's 3 terms, so it's a trinomial. So we're just going to do trinomial factoring, okay? If you don't remember, we're looking for what multiplies to 35, adds to 12. So multiply to 35 could either be 1 and 35 or 5 and 7, and that's it. Add together, that tells you to add, so we could either get 36 or 12. Obviously, we want the 5 and 7. Okay? Place in your parentheses. If it's plus at the end, they're both the same as the middle, so both are plus. Doesn't matter which one goes where because they're both positive. So x plus 5 and x plus 7 is fully factored. And that's it. That's the same thing as diamond factoring, yeah. I'm just showing what you did in your head in diamond factoring. Okay? Number 6. If I give you 3x plus 4y quantity squared plus 2 times 3x plus 4y minus 24. Now, on the difference of squares problems, they were a little bit easier to, if you didn't want to substitute, it was a little bit easier to negotiate. These are a little more difficult because they just look so big, okay? Don't worry about these. These are quantities, okay? If it's ever a parentheses, it's pretty much telling you this is a quantity. So what I can do is I can take that out and I can substitute in for something that just looks nicer, okay? It looks a little easier to factor, okay? So q squared plus 2q minus 24. This looks, for our brains, a whole lot easier to factor than this big quantity. Okay, so it's not that you couldn't do it. It's just that this is a little bit easier way to factor with a quantity. Okay, we're just going to kind of fake it out. So here, what multiplies to 24 would either be 1 and 24, 2 and 12, 3 and 8. A lot of people forget 3 and 8. Or 4 and 6.
4 and 6.
Okay, we're looking for the difference. So you could either get a 23, 10, 5, or 2. And we want the 4 and 6. Put in your 2 parentheses. Since it's negative at the end, you know you have to have 1 positive, 1 negative. 6 is the bigger number. Bigger number goes with the middle sign. So 6 goes with the positive, 4 goes with the negative. And Q breaks down. Now, you are not done. That's why I would recommend using a different color or something. Because a lot of people will say, oh, I'm done. And they all of a sudden factor it and it's an X. It doesn't have an X there. Okay? I substituted. So that means if I substituted, I have to put it back as an answer. So 3x plus 4y plus 6 times 3x plus 4y minus 4. Nothing is being distributed through. So you just drop that internal parentheses. So 3x plus 4y plus 6 times 3x plus 4y minus 4. And that is fully factored.
Why do you have to have the internal parentheses?
We want the internal parentheses just in case something does get distributed through. So like one of the ones we did at the beginning, this 3 had to be distributed through. So if you didn't have the internal parentheses, you wouldn't distribute it through correctly. Okay? And it's just mathematically correct to have parentheses first. Okay, so let's try another one. I'm going to say a plus 5b quantity squared minus 13 times a plus 5b plus 42. A plus 5b quantity squared minus 13 times a plus 5b plus 42. So here I'm going to substitute out a plus 5b. Instead, I'm just going to write in a q. Just makes it a little bit easier for our brains to factor this. So q squared minus 13q plus 42. Multiples of 42 are going to be 1 and 42, or excuse me, the factors of 42. 1 and 42, 2 and 21, 3 and 14, and 6 and 7. We are looking for what adds to give you those numbers. So 43, 23, 17, or 13. Place in your parentheses. It's plus at the end, so they both are the same as the middle. So we're going to have 2 subtraction signs.